What's poppin', dogs? Mr. Allen here. We're about to sketch the graph of this polynomial function with the following characteristics. We only got two of them here, man. It's going to be easy. Maybe. I don't know. We'll see. It's increasing on these two intervals from -2 to 3 and from 5 to infinity. And it has an absolute minimum. Interesting. Well, first off, if it has an absolute minimum, what does that tell us? What does that guarantee? It's an even degree function, and it's positive. So it's going to be going up on both sides. So whether this thing is say a quadratic like this, or perhaps a quartic function, right, degree 4, or even degree of 6, I don't know, bro, but it's something like that, right? It's positive, and it's an absolute minimum. Okay. It's increasing on two intervals. So if it's increasing on two intervals, it's got to at least be something like a degree of 4 here, because I'd be increasing in this section and I'll be increasing in that section there. So with no other information here, I'm thinking we can go with this quartic looking function right here and perhaps make this all work. So if it's increasing on those two intervals, I think it really helps to go ahead and break this graph apart. So I'm going to toss in some dashed lines here, okay, at -2 to +3. Right? So between these two, it's increasing. It's going up, right? And then from 5 to infinity, it's going up. So we've got increasing, we've got decreasing, we've got increasing. Over here, it's decreasing, okay? So just some kind of informal math notation here, right? Later on, you'll learn about things that have like asymptotes we use with dashed lines. So be careful with your usage there, but it'll help us break this apart right now. So I know that I'm decreasing here. So how about I do this? I'm going to go down, and then I know I gotta come up now because I'm going to change direction at this dashed line. And then I'm going to go up here and get to a high point, right? A relative high point. Okay, and now I got to change direction, and then I got to pop back up here and continue on to infinity and beyond. So let's take a look here. Do we have an absolute minimum? This would be my absolute minimum here, right? That's my lowest point on this graph. The arrows are pointing up. I don't have an absolute high point. I have a relative maximum or a local maximum and another local minimum, but that's my absolute minimum. So that checks off. Increasing between -2 and 3, so on -2 to +3 on that interval there, increasing, yep. And then increasing from 5 to infinity. Remember, infinity is our x value we're referring to. Negative infinity is our x value over here, right? The left and right sides of the graph. So it is increasing on that stretch there to infinity and beyond. It's increasing here. We have both of these things fit into this beautiful quartic function that's positive. That's an absolute minimum. Oh my goodness. That was fantastic. That was wonderful. I hope you guys enjoyed it as much as I did because that was pretty dang dope. Deuces, dogs.